Last time, we looked at how the CIA Triad works to keep a business's digital assets completely locked down. The goal was simple: protect the data from outsiders at all costs. But an isolated server cannot generate revenue. For information to have business value, it has to move. It has to be shared with employees, partners, and customers. To understand how organizations balance that need for access against the need for strict security, we are going to trace the path of data from a single desk all the way to a global infrastructure. The way a manager designs these communication pathways dictates how fast their enterprise can scale, adapt, and operate. Think about a manager at an independent retail store processing a customer's purchase at the front desk. That transaction starts on a personal area network, or PAN. This is a very small, short-range connection, like the manager's tablet pairing directly to a Bluetooth credit card reader. Once the payment clears, the tablet needs to update the store's stock levels. It uses the building's internal Wi-Fi to send that data to the back-office server. This creates a local area network, a LAN, which connects a variety of devices at a single geographic site. Because the hardware is entirely contained within the store, the connection is incredibly fast and easy to secure. However, it restricts the business's operations to that one physical building. Now, suppose that independent store is acquired by a national retail chain. At the end of the day, the manager must send their sales report to corporate headquarters across the country. A local Wi-Fi router cannot reach that far. The business now requires a wide area network, a system that facilitates communication between two or more distinct geographic locations. We tend to think of these long-distance transmissions as invisible signals floating through the air. But as this image shows, the internet is built on physical infrastructure, relying on thick bundles of fiber optic cable buried underground and running along the ocean floor. By tapping into these leased data circuits, corporate leaders can synchronize inventory and sales across thousands of local shops simultaneously. Routing a specific sales report through that massive public infrastructure requires a precise set of instructions to reach the correct headquarters server. The Transmission Control Protocol and Internet Protocol, or TCP/IP, divides data into packets. Each packet takes a different optimal route before reassembling. To prevent interception on public nodes, the system places these packets inside a secure, encrypted tunnel running through the public internet. That secure pathway is called a Virtual Private Network, or VPN. It authenticates the users and scrambles the communication so that outside observers cannot read the files in transit. Together, these protocols allow a business to leverage cost-effective public cables while maintaining the strict privacy required for enterprise operations. Once that sales data safely reaches headquarters, the marketing team needs to analyze it. Installing database applications on every individual employee's hard drive takes time and requires constant maintenance. Instead, the team uses cloud computing. They log into a software-as-a-service platform, like Salesforce, directly through the World Wide Web. The application and the data are hosted entirely on a vendor's remote servers. The company gains immediate access to sophisticated analytic tools that scale automatically as they hire more staff, freeing their own IT department from managing local software updates. Modern networks integrate directly into physical operations. Consider a logistics company transporting a shipment of temperature-sensitive pharmaceuticals across the state. The delivery trucks are equipped with internal thermometers that constantly record the cargo bay conditions. Because these sensors are connected to the network, they form a part of the Internet of Things, an automated system where physical objects gather and share data without human input. If the cooling system fails, those sensors use the 5G cellular network to instantly broadcast a warning. 5G provides the high-speed data transfer and near-zero latency required to send that alert the millisecond the temperature rises. The physical truck is now an active node on the company's network. The fleet manager receives the warning immediately and can reroute the driver to a repair facility before the cargo is ruined. As the business grows, the volume of network traffic creates a new hazard. During a major Black Friday event, millions of simultaneous customer requests can overwhelm the company's central servers. To prevent an outage, the system relies on AI network automation. Machine learning algorithms predict the incoming surge and automatically adjust traffic routing and bandwidth to keep the servers online, all before a human engineer even notices the spike. The system also utilizes edge computing. Rather than forcing every shopper's request to travel back to the main headquarters, the processing shifts to localized data centers situated closer to the customers, minimizing delay. This intelligent infrastructure maintains the customer experience and ensures the company continues making sales. We started with a single tablet connecting to a Bluetooth reader in one store. Now that same data flows across fiber optic cables, moves securely through encrypted VPN tunnels, and interacts with global AI systems, making split-second routing decisions. The underlying technology will only continue to evolve. Decentralized structures like blockchain ledgers are already being tested to verify and secure these massive chains of global business transactions. Think about a business you interact with regularly. If they overhauled their own network infrastructure, adding real-time sensors, cloud applications, or edge computing, how would it change the way they serve you?